The last thing you need to know about this chapter is how to calculate the perpendicular distance from a point to a line. The perpendicular distance from a point to a line, let's say that the point is let's say that the point is any point here, over here, so let's pick one. This point over here to this line is always, let me see if you can see, like this. It's always the perpendicular distance that goes to the point to the line. All right, this makes sense. You have lots of distances, but the perpendicular distance is always the smallest distance between the point to the line. This should be obvious. So if L is the line with a vector equation given by this, okay, position vector and direction vector, and B is a point with coordinates x, y, and z, then I'm going to explain the set of steps that you have to use to calculate that distance. Pay attention, there are lots of steps over here, so I want you to pay attention to every single one so that the whole thing makes sense. To help out, I just have here a little sketch of what's going on. So I'll have here the line L, here the point P. What I want is the perpendicular distance from P to this point over here. So that is the magnitude of that line over there. Okay? So step 0. The whole idea. The perpendicular line to L passing through P crosses L at point N. The perpendicular line passing on P crosses the line L on point N over there. Okay? The distance we want is the distance NP. All right? The magnitude of this vector NP. All right? To get this, we first need to find the coordinates of N on line L. So let's start with that. The first thing is to find the position vector ON. That is, the position vector of the point N, which is on line L. If it is on line L, then the position vector is going to be based on the equation of line L, and is going to have a particular value of lambda, the multiplier. Okay? Don't forget, this allows you to get any point on line L. For a particular point, this is going to be a specific number that I'm going to call N. All right? So what you have here, the ON, this is just the position vector of L. This is the direction vector of L. And N is going to have a specific number. So the whole thing of what we're going to do is to try to find out the value of N. Okay? What is the next step that I did? I just multiplied N by all the components over here on the direction vector of L. And I put everything together in column vector. Finding the exact position of L involves finding an exact value for N. I already mentioned that. So step 2, find, in terms of N, that you don't know yet what it is, the line vector NP. Now we need to get the line vector NP. If what we want is the magnitude of NP, we first need the line vector NP. Okay? How do we do that? Well, NP is going to be equal to OP, the position vector, minus OP, the position vector of P, minus ON, the position vector of N. Makes sense, we already know that for a long time. So what is OP? OP is given by, as we can see here, by the coordinates of P. ON is given by that. So again, what am I going to do? I'm going to put everything as a single column, okay? So I just minus this, and I put x minus a, let me see one thing. Yeah, okay, I put everything in one single column. Now, step 3, NP is perpendicular to L, which means that it is perpendicular to its direction vector, the DEF. This is the direction vector, this is the direction vector of line L. So we know that NP must be perpendicular to that. Okay, what does perpendicular mean? The scalar product of these two must be therefore 0. Okay, so what do? We multiply this, and what is this again? This is NP, by this. What is this? Is the direction vector of line L, and this must be 0. So we just do the multiplication and equal it to 0. We will now have a linear equation with only one unknown, which is n. Don't forget that all of this, everything that is not n on the question, these are going to be numbers, okay? So you will have here an equation in terms of n. Solve the equation and you'll find finally n. Now that you have n, you go and substitute it on NP over here. And this will give you what? You'll have the actual coordinates. And now all you have to do is to get the magnitude of NP. Now that you have the coordinates of the vector NP, you just need to calculate the magnitude of NP, which is the distance that you were looking for since the beginning.